Hi everyone. In this video, we are going to understand expectation value, how to find the expectation value in case of discrete probability distribution and in continuous systems, and how to find the expectation value in the quantum mechanics. Okay, I'll try to briefly explain the mathematical perspective. I mean, like how to find actually the main motivation of this video would be the calculation point of view. I would not go into the details of the conceptual background of the expectation value, but rather directly how to find the expectation value, which is actually one of the most important topic in the quantum mechanics and in the statistical physics. Okay, let's go directly into the topic. So let's see one by one. Let's go with first part, which is actually the expectation value in case of the discrete probability distributions. Now, if we have set of possible values, if we have set of possible values, let's say we have values like x1, x2, x3, and so on, and each value has a probability. Okay, so these are possible values and each value has probability something. This has probability p1, this has probability p2, this has probability p3. Then the definition says the expectation value of x will be given by summation of I starts from like say 1 xi pi. Okay, while I starts from 1 2 3 so on. Okay, the number, oh sorry, not 3 here because we have so many, let's say n. So this is the definition, but let's not remember it for right now. Let's go some different example, then you will understand what does it mean, the expectation value. Let's say this is an example here. So we have been told to find the expectation value. Here this numbers, these 14 15 16 22 24, this represent as some age. Okay, and represent the number of the people having the age 14, number of the people having the age 15 is 1 number of the people with the age 16 is some sort of x. This 14 15 16 is some sort of x. Okay, this x, x1 x2 x3, like this time it's age. Okay, we have to, in order to find the expectation value or the average value, we need to find the probability of each value. So because we would need the probability in expectation value measurement. So fundamentally what it means, that we need to find the probability of this 14, age 14. Okay, in order to find the expectation value, we need to find the probability of each measurement, each age. Here this number is age actually. So we have total number of the people 1 2 5 7 and 9 and 5, which is 14. So total number of persons we have equals 14. Okay, now that the people with the age 14 is 1 there. Okay, so what is the probability of age 14? What is the probability of age 14? Can you people guess? So what is the probability of a getting the age 14 if I choose random one people? So it's 1 divided by 14. And what's the probability of age 15? That would be 1 divided by 14. And what is the probability of getting a person with the age 24? Is 2 divided by 14, which is 1 divided by 7. So this way we would be able to find the probability of each measurement. I hope you get how to find the so it's simply the number of the persons with that age divided by total number of the persons. Now we have easily found the probability of the each measurement. So this is done. Now this is given, so we can easily say that if this is some j, let's represent it this time j, or let's say x. So probability of x is given by simply number of the people with the age x divided by total number of the people. This is the formula I used here. Probability of getting a person with the age x is given by number of the persons with the age x divided by total number of the persons. And now there is a very important thing, the expectation value. That means now we have been told to find the expectation value of x. Okay, so we know it's given by summation of x with into probability of x. A simple formula. I runs from the number of the values we have been given in the question. So here we have 1, 2, 3, 4, 5, 6 values. So I will run from 1 to 6. Okay, so that means this time the x is first of all is 14 into probability of getting the 14. We know it is 1 by 14, so 1 by 14 plus we have to do the summation. Then the next measurement is the next value is 15, and it is probability is 1 by 14 plus then 16 into its probability 3 divided by 14 plus 22 into probability of this 22. How many persons are there with the age 22 is 2 divided by 14 plus 24 into probability 2 divided by 14 plus 25 into probability this. Okay, so basically it is the same formula here, XIPI, or you can write here XI into probability of that XI. Okay, the measurement and its probability plus measurement, its probability value, its probability value, its probability value, its probability. It's very simple. So we can write it as 14 plus 15 plus 16 into 3 plus 22 into 2 plus 24 into 2 plus 25 into 5 whole divided by 14. Am I okay with this? If you do the sum of these whole things in the numerator, it would be 294 divided by 14, which is equal to 21. So 21 is the average value or the expectation value. I'll take another example. So basically the expectation value again, there is no person with the age 21 there. If you see, there is no person with the age 21. So average value doesn't mean that the value is there. Okay, it may be there and it may not be there. Let's do another basic simple example. Let's do the example of rolling a die. Rolling a die. So we have the x1 measurement, x2 measurement value, x3. There are only 6 possible values. Okay, 1 to 6. So basically this is 1, 2, 3, 4, 5, 6. Each this time each has a probability of 1 by 6, 1 by 6, 1 by 6, 1 by 6, and we know each has a probability of 1 by 6. Now if somebody asks us like what is the expectation value of x, then what we'll do, the value into its probability 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. So basically it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 whole divided by 6. Okay, so basically if you do, it's 6, 10, 15, 21 divided by 6, which is 3.5. Okay, so this time the expectation value is 3.5. But remember one thing, in some calculations, what the formula, some books write, they write the expectation value formula as a summation of I xi into probability of I, the same thing. But what they do, they take the denominator as summation of p of xi. Then what they do, they sum these all probabilities in the denominator, because sometimes when we go into the quantum mechanics or in the continuous systems, the summation of all the probability is not sometimes one. Okay, this is something which comes from the normalization. Okay, this comes from the normalization, but in above cases, if we do the sum of the probabilities here like this, so it would be 6 times 1 by 6. Okay, because it's 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6, so that would be 1, so we don't need to write it here. So again here, what is the probabilities? Sum is 1 by 14, 1 by 14, 1 by 7. If we what is the probability? 24. 24 is 2 by 14. This is 3 by 14. This is 2 by 14. This is 5 by 14. And so if we do summation of all the probabilities, I runs from 1 2 3 4 5 6, 1 to 6. So it's like first one is having 1 by 14 plus, then it's 1 by 14 plus 3 by 14 plus 2 by 14 plus 2 by 14 plus 5 by 14. If we do it like 5 twos, 7 9 10 11 3 14, 14 by 14, it's again 1. Okay, what we need to remember, actually, for more general purposes, expectation value of x should be like I xi into the probability of I, or probability of this measurement, divided by summation of all the probabilities. Okay, or sometimes it's right, it's written like this. Okay, so basically you must remember this formula. But generally they always give that summation of all the probabilities equals 1, so we don't need to worry about, but just check it once whether it's 1 or not. If it's not 1, then you need to put that value in the denominator. I hope you get the idea of how to find the so again, there is one more thing. If somebody asks you what is the expectation value of the x square, you don't need to do anything. What you have to do is it's like here, x, in place of the x we have x square now into the probability of the xi, okay, divided by summation of probability of xi. We only change, let me put it in a proper box. Okay, now yes, basically if somebody now asks you like expectation value of x square here, what we do here, we only write here as the 14 square into probability of the 14, not 14 square, because it would be same. Okay, 1 by 14. And then if somebody asks you expectation value of x square, so here it would be 14 square, 15 square, 16 square, 22 square, 24 square, 25 square, else would be same. Okay, I hope you get the idea, and you have to check the denominator whether it's 1 or not, because sometimes it's not 1. Okay, this is the basic idea of the expectation value in case of the discrete systems. Now let's move to the continuous system. Let's move to the second part, which is the continuous system. So basically in the continuous system we have a certain range where we need to find the expectation value actually. Here we have a range. Here we have a range. So the probability, we're again going to find the expectation value, okay. So probability of finding a value in x and x plus dx. Okay, so basically in the continuous system the formula is same. Let me write it one more thing. So here expectation value of x square is this, And if somebody asks like expectation value of f of j, some random number, okay, some random value, so it would be simply summation of j equals 0 to infinity f of j, same thing, into probability of j. And remember, summation of probability is we have to add it. Okay, this is the general formula for anything. Okay, so now let's go to our main topic. In the continuous systems, the formula would be same. Actually, now we have a very important term which we called as the probability density. Probability density. And I will say that I will denote it by the rho of x always. Okay, rho of x is the probability density. Rho of x, I'll always, most of the books use rho of x as the probability density. Okay, so in a probability that probability probability that probability probability that x lies between a and b. In continuous system, we have, I told you that we have a range. What's the probability that the value lies between 16 and 17? If I choose a random person in the above example, what's the probability that the person with the age between 16 and the 1 month? You understand? So there is some sort of range. So probability that x lies between a and b, this a and b is a range, is given by is given by the integral probability ab equals the range a to b rho of x d of x. This is the formula for the probability. We have to remember this formula always, where this rho of x is the probability density. This is the probability density. This is the probability density. Rho of x is the probability density. And I would suggest that always remember this probability density as rho of x. Some books use f of x, some books use p of x, but I would suggest remember it as a probability density, because we know the density, in case of the electrodynamics, we use volume charge density as rho of x. Yeah, rho of, rho we use as a density as rho, not some f of x or the p of x. So I would suggest like there's a thing that you can do it yourself. So rho of x is the probability density. So now one thing is sure, that expectation value of x now is given by minus infinity to plus infinity, the value into the probability density into dx. Okay, in discrete what we had, so it was summation x into probability of that x. Okay, but here we have x into probability density and then integration. Obviously we have to do the integration. So I'll do an example. So expectation value of x, and if somebody asks you what is the expectation value of f of x, some different quantity, so it's simply minus infinity to plus infinity f of x, the quantity, into the probability density d of x. So either this probability density will be given, so actually it is given in the question if you want to find the expectation value of anything. Okay, it must be given in the question, this rho of x, which is actually the probability density. Remember again, if you want to find the expectation value of anything, so integral minus infinity to plus infinity f of x, that quantity, into the probability density. Okay, so I'll do a question on it, then you'll understand what I mean. Okay, so I wrote here a question, and we'll understand the both concept is that how to find the probability and how to find the expectation value. So I told you the formula, that the probability of anything or any value that lies between a and b, is given by integral a to b rho of x d of x, where rho of x is the probability density. Okay, just like here we have been given as the rho of x as the probability density, we have to find the probability the particle lies between 0 and half. Okay, well, probability density is given as a some constant when it's like this 0 and 1. This, if this is some x-axis, this is origin, and this is some 1, then probability density is some constant a here. Okay, some a here as some, this is some y-axis. Okay, 0 to 1, 0 to 1, it is a. Now we have been told to find the probability of lying between 0 and half. So we'll use P of AB equals 0 to 1 by 2 into probability density d of x. But again, we have to take care of the normalization. I told you, just in case of the discrete systems, what we did, what we did, let me tell you what we did here. We divide the denominator. Actually, here, if we do the summation of all the probabilities, it's 1. So we didn't care about in expectation value of x about that thing. So it's like summation of pi's. Similarly, in the probabilities, we didn't care about that thing, because if we see it's always 1, so we didn't divide here as probability of getting 14 is 1 by 14. If we do the divided by the summation of pi's, that would be 1 again. So we didn't care about that thing. Okay, so similarly we have to care about here divided by actually uh, from minus infinity to plus infinity, actually probability density dfx. Okay, so similarly here the actual range was between 0 and 1 is some sort of the minus infinity to plus infinity. Okay, so we have to divide by 0 and 1 rho of x d of x. Okay, this is some sort of the normalization. You have to take care of this thing always. But most probably in most questions it's given as 1, but yes, we have to take care of this thing. So it's like 0 to 1 by 2 probability density. Since it's a between 0 and 1, so between 0 and 1 by 2 it's again a. So it's like a d of x divided by whatever the range is given. It's 0 and 1. Okay, it's some sort of the whole range. And then a d of x, a is some constant, then it's 1 by 2 divided by a is some constant and 1, so it will give us 1 by 2. Otherwise, if we don't do this part, you check, if we don't do this part, what we'll get as, we'll get a by 2. We'll get a by 2 as the answer. Okay, so similarly expectation value of x will be given by, see, expectation value of x is given by the range. We have the 0 and 1 by 2. We have to find the expectation value. Okay, we don't need to take care of the 0 and 1 by 2, so it's like 0 and 1, 0 and 1, x into probability density d of x divided by whatever the range is again 0 and y, rho of x d of x, 0 and 1. Okay, we have to take care whole range. Okay, so again 0 to 1, x and probability density between 0 and 1 is a d of x divided by 0 and 1, a d of x. There is no problem in that. Okay, and it's like a is x squared by 2, 0 and 1 divided by a is x, 0, 1. So a will go, so it's 1 by 2 and 1 divided by 1, it's again 1 by 2. So expectation value is again 1 by 2. So if they ask you the expectation value of x square, what we do is 0 to 1, 0 to 1, the quantity into the probability density d of x divided by 0 to 1 probability density d of x. In some notations, this rho of x is actually psi square. Okay, so expectation value of x is actually given by in this case 0 to 1 x psi square dfx divided by 0 to 1 psi square dfx. Okay, I hope you get you get the idea of the notations in the continuous systems. So you have to only get the idea of the expectation value, else you know how to do the things. Now let's move to the quantum mechanics. In quantum mechanics, what we do, we have some operators. Okay, and if we have some operator, because whatever we do in the quantum mechanics, we do it through operators. If we want to find the position of the particle, we use a position operator. If we want to find the momentum, we use the momentum operator. If we want to find the kinetic energy, then we use the kinetic energy operator. So expectation value is given by integral psi star x. We have to sandwich that operator between psi star and psi. Okay, this is a general formula. And now again, it's we have to take care about the normalization. If the wave function is not normalized, then we have to write it as a psi star a operator psi d of x divided by integral psi square d of x. This is some sort of the probability density. This is again the same thing, because if you write above, if you write it in the above notation, so it's like, because a psi star a psi can be written as a psi star psi, so that would be same. Okay, so it's like a same, the number, the measurement into the probability density, this formula, this formula. And and it's easy, if you have to find the expectation value, then we write it as from, let's say, minus infinity to plus infinity, and from minus infinity to plus infinity. Okay, but yes, we have to take care of this normalization, because sometimes the wave function is not normalized, and we have to normalize it. Okay, so if I take an example in this case, let me give you an example. So let's do this example by using the formula. So this is the wave function given. It's actually the normalized wave function. So we don't need to take care of this denominator, but yes, we can do it. There is no problem. Now we have been told to find the expectation value of p. So the general formula of the expectation value of anything, so it's like minus infinity to plus infinity psi star, and we have to sandwich this operator between psi star and psi dx divided by, if not normalized, then you have to divide by this thing. But if this is normalized, this would be 1, because in above case it's normalized, so it is 1. We don't need to take care of this thing. So simply minus infinity to plus infinity psi star, because it's a real valued wave function, so it's like a e to the power minus alpha x square, or I should write a star into p in place of the momentum operator. We know a momentum operator is given by minus iota h cut d by dx. Okay, so it's like minus iota h cut d by d of x of psi, which is a e to the power minus alpha x square d of x. Since denominator is 1, we leave that. So a into, let's take this a out, a into, it would be mod of a square. Now minus infinity to plus infinity is e power minus alpha x square minus iota h cut d by dx of e power minus alpha x square dfx. Okay, so it's actually given a in the question. We can find that by normalization condition. A is given by 2 alpha divided by pi to the power 1 by 4. Okay, you can find it from here. okay, this a, because it's normalized. It has been told that the wave function is normalized. So this thing is equal to 1, then you can find from that condition a. Okay, since this lecture is not meant to find that thing, we'll focus on the normalization. We'll find we'll focus on the expectation value. So basically mod of a square, since it's given as 2 alpha, is 2 alpha divided by pi to the power 1 by 4, 1 by 4 whole square. So it will go, if you evaluate this thing, minus infinity to plus infinity e power minus alpha x square and minus iota h cut e power minus alpha x square into then it's minus alpha 2 of x, okay, d of x. Okay, so d by e power minus alpha x square into d by d of x of minus alpha x square. I believe I did right. So it would be minus alpha 2x. Okay, that's great. So it's like 2 alpha divided by pi to the power 1 by 2. And so 2 alpha, this minus minus will go, 2 alpha iota h cut, 2 alpha iota h cut. Let's take these things out, minus infinity to plus infinity. So there would be x, this x, and e power minus alpha x square, and this is e power minus 2 alpha x square d of x. If that is okay with you, then let's solve this integral. So we can write it as 2 alpha iota h cut, and then we have 2 alpha by pi 1 by 2, and this integral, this integral, if we see it's an odd integral actually. If you check, because if we replace x by minus x, we get minus times. Okay, so it's actually an odd integral. X, this whole function, x e power minus 2 alpha x square, it's an odd function, and integral is from minus infinity to plus infinity, so it is actually 0. So we get 0 as the expectation value of p. Okay, since the wave function was real and it's symmetric, okay, that is an even function. A symmetric probability distribution simply means that equal probability of momentum being positive and the negative, so average would be 0. So that's the main idea of that thing. Okay, so I told you the basic idea of how to find the expectation value. So in case of the discrete system, in case of the continuous system, and in case of the operator, so in case of the operator, we have to sandwich this p between the psi star and the psi, and we have to check whether the function is normalized or not. If they say the wave function is normalized, then we don't need to take care of the denominator, but if they say is not normalized, then we have to evaluate the denominator as well. Thank you so much.